Space. It exists alright. For the past few years, SpaceX has remained a leader in space travel and innovation. Their reputation was heavily strengthened just a few days ago. On September 18, 2021, a mission of 4 civilians aboard the Dragon capsule successfully returned to Earth. This marked the first time ever a mission of all civilians was completed. As we reflect on this momentous accomplishment, I raise the question, why are we even going to space? We should also recognize there's still a lot of work to be done when it comes to space travel. However, I'm also going to share with you several ways we're heading in the right direction. There are 4 main reasons that are typically agreed on when it comes to justifying why we should be going to space. Number 1, it improves life on Earth. Every year, NASA releases a list of technologies they've been working on that improve civilian life on Earth. The publication is called Spin-Off. Some of the technologies from this year's edition have created odor-eliminating shoes, improved tankless water heaters, a new air filtration system, and more. An investment in spaceflight is an investment in improving your daily life. Number 2, it's a giant fire drill. Why do we have fire drills? Well, it's to prepare us in case there's an actual fire. The more fire drills, the more prepared you'll be if you have to evacuate a building in the case of emergency. Well, what if we took that concept but applied it on a much larger scale? What if a large asteroid crashes into the Earth? What if, in a long time from now, the sun engulfs the Earth? Then what are we gonna do? Fear not. If we continue supporting space travel, then we'll have the means of evacuating the planet if we need. Number 3, it benefits the economy. Over 17,000 people work for NASA. That means that 17,000 driven individuals are not only working on solving big problems, but also receiving financial return for their work. Now, some may ask, well, why do we need the government to pay for these people? Why can't spaceflight just be a private industry with the rise of companies like SpaceX and Blue Origin? My answer to that is simple. Private companies have different incentives to work on space technologies. They need to work on technologies that will provide them a return on investment, like asteroid mining. Meanwhile, NASA is not only able to work on these problems, but also problems that affect the lives of the people here on Earth. For example, if we didn't have NASA, then there wouldn't be a National Weather Service. Number 4, exploration. It's what we do. You're human, presumably, which means that you're likely a very curious being. You question the world around you and wonder what else is out there in the world. Humans have always been like this. It's in our roots as hunter-gatherers. We've been able to conquer all 7 continents. Why stop there? With space technologies, we are able to even further expand our knowledge of the world and discover what the final frontier has to offer. Let's return to the present day. We are always full of awe as we see rockets take off and head to space. However, these rockets are not actually a good solution to long-term space travel. Here's why. Our rockets are called chemical rockets because they use chemicals to fuel themselves, which can be seen with the exhaust, for example, which is made out of hydrogen. They utilize Newton's third law of motion. For every force applied from one object onto another, there is a force equal in magnitude and opposite in direction acted onto the original object. In this case, we push the exhaust down to make the rocket accelerate up. The problem is that for these rockets utilizing Newton's third law, they have to carry a lot of fuel with them to escape the gravity of the Earth. A lot. A rocket's propulsion system, the engine, fuel, and oxidizer, can take up 96% of a rocket's mass. Why is this? Because of the rocket equation. The rocket equation goes as follows. The change in velocity of a rocket equals the velocity, with respect to the rocket, of the exhaust times the natural logarithm of the initial total mass of the rocket divided by the final total mass of the rocket. So what exactly does this mean for a rocket? Let's assume we want to go to the star system Alpha Centauri. The final mass of the rocket will be 0.1 grams, let's just say. We can estimate the exhaust velocity of a chemical rocket to be 5 kilometers per second, which is the most efficient exhaust velocity to date. Our change in velocity will be 26,200 kilometers per second to get there. When we do the math, it turns out that the mass in grams of the amount of fuel we'll need to propel the rocket is 10 to the 2,200th times the mass of the observable universe. Yeah, I don't think that makes sense logistically. While chemical rockets make sense for trips to the ISS, if we want to get to Mars and beyond, we're gonna need a better way of doing so. Here are 3 space technologies that we can use to help us reach Mars. Ion thrusters. Ion thrusters are a possible replacement for chemical rockets. The engines use electromagnetic fields to eject atoms, don't forget Newton's third law, in order to accelerate the rocket for months at a time. For reference, you can accelerate a chemical rocket for 10 minutes. Basically, instead of hot gases, ion thrusters eject ions. Ions are just atoms or molecules that have an electric charge. These ions will be positively charged. This means that they've lost an electron. The ions are actually created by the engine itself. The engine creates a plasma by bombarding neutral atoms of some gas, like xenon, called propellant atoms, with electrons. The collisions release even more electrons, coming from the gas, turning the propellant atoms of the gas into positively charged ions. The ions are directed into a magnetic field, accelerating them into space with tremendous velocity. Newton's third law takes care of the rest. Let's revisit the rocket equation. With chemical rockets, we can have an exhaust velocity of 5 kilometers per second. However, with ion thrusters, our exhaust velocity can be as high as 90 kilometers per second. This allows for a much more efficient acceleration. While the thrust of ion engines is relatively small, they can accelerate for months at a time, making it a promising space technology. Solar sails. The idea of solar sails is to propel a rocket with a sail, just like we do with some ships on Earth. However, instead of the wind, we'll utilize the sunlight that we get from our sun. When sunlight reflects off the sail, it also gives it a push. The reason for this is because while light does not technically have a mass while it's at rest, it does have momentum because it's a wave in addition to being a particle. Here's a potential concern. As the ship moves further away from the sun, wouldn't you get less sunlight and hence less of a push? Well, yes, but it really doesn't matter. Don't forget, space is a vacuum and doesn't have any air resistance like Earth does. This means that the initial push will enable the spacecraft to coast without losing any velocity. NASA is already looking at solar sails as a viable way to propel spacecraft. Antimatter propulsion. Let's quickly discuss what antimatter is. You can think of antimatter as regular matter, but all particles have the opposite charge. This means that antimatter electrons have a positive charge instead of a negative charge, hence why they're called positrons. Antimatter also has the ability to annihilate if it collides with its own partner particle. For example, if an electron collided with a positron. Why am I even explaining antimatter to you? Well, it's because we can utilize antimatter to propel rockets. The idea is that we can take as much of the energy as possible from an annihilation and use that energy to heat hydrogen. If we can heat the hydrogen to a very high temperature, then it can be blown out the back of a rocket. This propulsion would be the most efficient ever developed, as 100% of the mass of the matter and antimatter is converted into energy. An annihilation releases 10 billion times the amount of energy a chemical rocket releases. One main problem that must be addressed before antimatter propulsion becomes a reality is that matter and antimatter have to be kept separate before the rocket launches, which is quite difficult to do. However, if we can create antimatter propulsion systems, we can retrieve velocities of 40% of the velocity of light, enabling us to reach Alpha Centauri in potentially less than a decade. With NASA trying to reach the Moon and then Mars in the coming years, we must look even further into the future. It will not be easy to develop the technologies to help us go beyond Mars, but if we start working on it, the results will be invaluable. Thanks so much for watching.